From the outside, Uranus looks like almost nothing is happening. A smooth, pale blue-green marble hanging in the dark, with barely a cloud band or a storm visible to the naked eye. It is, by appearances, the most boring planet in the solar system. But that calm surface has always been a kind of mask. Scientists have suspected for decades that underneath that quiet exterior, Uranus is one of the strangest, most chaotic worlds we know of. And in January of 1986, humanity finally got the chance to find out just how strange, when a small, robotic spacecraft called Voyager 2 became the first, and to this day the only, machine ever built by humans to fly past this planet up close. What it found didn't just add a few footnotes to the textbooks, it rewrote what we thought we understood about how planets are supposed to work. Let's start with the obvious oddity, the one you can actually see. Every other major planet in our solar system spins more or less upright, like a top, with its axis pointing roughly perpendicular to the plane it orbits in. Earth tilts about 23 degrees. Even Saturn, with its dramatic rings, only tilts about 27 degrees. Uranus tilts about 98 degrees. That's not a lean, that's sideways. Uranus doesn't spin like a top. It rolls like a bowling ball, cartwheeling around the sun on its side while every other planet spins upright around it. Imagine a merry-go-round where every horse rotates normally except one, which has somehow tipped over and is now rolling along the ground instead of spinning in place. That's Uranus, forever. This extreme tilt means the seasons on Uranus are unlike anything we experience on Earth. Because one pole points almost directly at the sun for a quarter of the planet's 84-year orbit, that pole gets roughly 21 straight years of continuous daylight, followed eventually by 21 straight years of unbroken night. Picture being born at the start of a Uranian summer and growing into an adult before ever once seeing a sunset. Meanwhile, the equator, which usually gets the most consistent sunlight on most planets, ends up experiencing a bizarre double sunrise, double sunset pattern as the planet's orientation shifts across its long year. For a long time, scientists could only theorize about why Uranus ended up this way. The leading explanation, and still the most widely accepted one today, is that early in the solar system's history, Uranus was struck by something enormous, quite possibly a rocky, icy body close to the size of Earth itself. That impact wouldn't have just left a dent. A collision of that scale carries an almost unimaginable amount of angular momentum, enough to knock a young, forming planet clean over onto its side and set it spinning in a completely new direction. Some researchers have proposed it might not have been a single catastrophic hit, but a series of large impacts that gradually tipped the planet further and further over. Either way, the fact that Uranus's moons and rings largely orbit in that same tilted plane rather than in the original upright orientation suggests whatever happened early enough and violently enough to reshape the entire system around the planet, not just the planet itself. That's the visible mystery, the one you could work out just by pointing a telescope at Uranus and watching how it moves. But Voyager 2 was built to look deeper, literally, using instruments designed to sense things no telescope on Earth could detect. And when its magnetometer switched on as the spacecraft approached in January 1986, it picked up something nobody expected. Every planet we'd studied up to that point, from Mercury to Saturn, had a magnetic field that behaved in a reasonably predictable way. Generated deep inside the planet by the movement of molten or metallic material, these fields tend to align fairly closely with the planet's spin axis, the same way Earth's magnetic North Pole sits close to its geographic North Pole. Uranus broke that pattern completely. Its magnetic field is tilted a staggering 59 degrees away from its axis of rotation, and it isn't even centered on the planet. The source of the field appears to be offset from Uranus's actual center by roughly a third of the planet's radius, shifted off toward one side entirely. To picture how strange that is, imagine Earth's north magnetic pole wasn't anywhere near the geographic North Pole, but instead sat somewhere over the Sahara Desert, and the entire magnetic field wasn't even centered on the planet's core, but was instead offset toward, say, the Indian Ocean. That's roughly the scale of lopsidedness. Voyager 2 found at Uranus. Because the magnetic axis is so wildly misaligned with the spin axis, and because the planet itself is already tipped on its side relative to its orbit, Uranus ends up with a magnetic environment that essentially tumbles and wobbles chaotically as the planet rotates. Scientists have since described it as behaving almost like a corkscrew, twisting and spiraling out into space in a way no other planet's magnetic field does. Some later analysis even suggested the magnetosphere effectively opens and closes on a kind of switch-like daily rhythm as this lopsided field rotates and interacts with the stream of charged particles flowing out from the sun. For years, this was treated as one of the defining, permanent facts about Uranus, proof that something deep inside the planet generates a magnetic field in a fundamentally different way than the metallic cores of rocky planets do. Rather than being generated in one clean layer, researchers now suspect the field might be produced within a slushy, electrically conductive layer of compressed water, ammonia, and methane inside the planet's mantle, a layer that isn't stable or deep enough to produce the kind of neat, centered field we see at Earth or Jupiter. Interestingly, newer research digging back through the original Voyager 2 data has added a fascinating twist. Some scientists now believe that Voyager 2 happened to catch Uranus's magnetic environment in an unusually squeezed, compressed state, caused by an unusually strong gust of particles from the Sun arriving in the days before the flyby, a set of conditions estimated to occur less than 5% of the time. If Voyager 2 had shown up just a few days earlier, it might have measured a noticeably different, less extreme magnetosphere. It doesn't undo the strange tilt and offset of the field itself, but it's a humbling reminder that our entire understanding of this planet's magnetic behavior is still built on a single, brief flyby, more than 3.5 decades old, that may have caught the planet in an atypical moment. Voyager 2 didn't stop at magnetism. As it swept past, it also turned its cameras and instruments toward the space immediately around Uranus, and found a system far busier than anyone expected from a planet that looks so plain from Earth. Before the flyby, only 5 moons of Uranus were known. Voyager 2's cameras spotted 10 more previously undiscovered moons in the data it sent home, more than doubling the known moon count in one pass. Decades later, scientists revisiting the original Voyager 2 data found evidence of yet another moon hiding in the numbers. Today, with additional ground and space telescope observations added on top of what Voyager found, Uranus is known to have around 28 moons, a strange miniature solar system of icy bodies orbiting a planet lying on its side. Among the moons Voyager 2 photographed up close for the first time was a small, dark, heavily cratered world barely 100 miles across called Puck, a moon so battered by impacts over billions of years that its entire surface looks pockmarked, almost like a golf ball. But Voyager 2 also gave us our first real look at the larger, previously known moons of Uranus, and what it found there was arguably just as strange as anything happening on the planet itself. One moon in particular, called Miranda, turned out to be one of the most geologically bizarre objects Voyager 2 photographed anywhere in the entire outer solar system. Its surface isn't uniform. Instead, it's a jumbled patchwork of wildly different terrains slammed together, smooth plains sitting right next to enormous grooved and ridged formations, and cliffs that plunge for miles far taller than anything on Earth. For a body barely a few hundred miles across, that kind of violent, chaotic geology suggested Miranda might have been smashed apart by a massive impact at some point in its history, and then gravitationally reassembled itself back into a moon, its shattered pieces fusing back together into a surface that looks like nothing else we've ever photographed. Then there were the rings. Ground-based astronomers had already detected a faint set of rings around Uranus back in 1937, discovered almost by accident while watching the planet pass in front of a distant star, and noticing the star's light flicker as unseen material blocked it. But nobody had ever actually seen those rings up close until Voyager 2 arrived. The spacecraft confirmed the existence of the previously known rings and discovered 2 entirely new ones on top of that, dark, narrow bands, made up of debris ranging from fine dust up to chunks the size of boulders. Unlike Saturn's bright, wide, icy rings, Uranus's ring system is dim, narrow, and charcoal dark, likely made from material that's been chemically altered and darkened by billions of years of radiation exposure. Scientists still debate exactly how these rings formed, whether from the shattered remains of a small moon torn apart by gravity, or as leftover debris from the same ancient cataclysmic event that may have knocked Uranus onto its side in the first place. And then there's the atmosphere itself, the thing that gives Uranus its pale, almost featureless blue-green color. Voyager 2's instruments confirm that Uranus's atmosphere is overwhelmingly that methane is what gives Uranus its color. It absorbs red wavelengths of light while reflecting back blue and green, producing the planet's distinct cyan tint, visibly different even from Neptune, its closest relative. Deeper down, scientists suspect layers of clouds containing hydrogen sulfide, the same chemical responsible for the smell of rotten eggs, meaning that if you could somehow survive the crushing pressure and lethal cold long enough to take a breath there, Uranus would genuinely stink. Speaking of cold, Voyager 2's measurements confirm something else deeply strange. Uranus is the coldest planet anywhere in the solar system, colder even than Neptune, despite Neptune sitting significantly farther from the Sun. Temperatures in its upper atmosphere can drop below minus 220 degrees Celsius. That's odd because every other giant planet examined so far radiates noticeably more heat out into space than it receives from the Sun, leftover warmth still escaping from the violent process of formation billions of years ago. Uranus barely does this at all. Its internal heat output is puzzlingly close to nothing, and scientists still don't have a confirmed explanation. One leading theory ties this directly back to that ancient sideways tipping collision, suggesting the same impact that knocked the planet over may have also scrambled its internal structure in a way that trapped heat deep inside, preventing it from rising and radiating away the way it does at Jupiter, Saturn, and Neptune. If that's true, the very same cosmic accident that gave Uranus its bizarre sideways spin might also explain why it's the coldest world we've ever measured, a strange twist for a planet that otherwise looks so unremarkable from a distance. It's worth remembering just how recently Uranus even entered human awareness in the first place. Unlike Mercury, Venus, Mars, Jupiter, and Saturn, all visible to the naked eye and known since antiquity, Uranus wasn't identified as a planet until 1781, when astronomer William Herschel spotted it through a telescope and initially assumed he'd stumbled across a comet. Further observation eventually revealed it was something else entirely, the first planet ever discovered using a telescope rather than the unaided eye. That alone says something about how faint and remote Uranus really is, sitting roughly twice as far from the Sun as Saturn, distant enough that its very existence went unnoticed through the entire span of recorded human history before that point. So when Voyager 2 finally reached it in 1986, it wasn't refining an already well-studied planet. It was giving humanity its first genuine close-up look at a world we'd barely had 2 centuries to even think about. It also helps to place Uranus next to its closest cousin Neptune, because the comparison highlights exactly how unusual Uranus is. The two are often grouped together as the solar system's ice giants, similar in size, similar in general makeup, both tinted blue by methane in their atmospheres. Voyager 2 visited Neptune 3 years later in 1989, and found a magnetic field there that was also tilted and off-center, though less severely than at Uranus. But Neptune, unlike Uranus, gives off an obvious surplus of internal heat, and its atmosphere is considerably more turbulent, with visible storm systems and fast-moving cloud bands, that Uranus mostly lacked. During the relatively quiet season, Voyager 2 happened to catch it in. That contrast is a big part of why Uranus continues to puzzle scientists specifically. It isn't simply an ice giant behaving the way ice giants are expected to behave. It's the outlier even among outliers, colder than it should be, quieter than it should be, shaped by a violent history we still can't fully reconstruct from a single flyby's worth of measurements. In the years since Voyager 2 departed, telescopes have kept chipping away at the mystery even without another spacecraft making the trip back. The Hubble Space Telescope and, more recently, the James Webb Space Telescope have both captured detailed images showing faint atmospheric bands, occasional storm activity, and a surprisingly bright polar cap that seems to shift as the planet's extreme seasons change, hinting that Uranus isn't nearly as featureless and static as it appeared back in 1986. Some of that apparent stillness Voyager 2 recorded may simply have been a matter of bad timing. The spacecraft happened to arrive during the planet's southern hemisphere summer solstice, a season when atmospheric activity may naturally quiet down, only for storms to resurface as the decades-long Uranian seasons shift. Newer infrared observations have picked up powerful storms and fast, banded winds essentially invisible during the Voyager 2 encounter, a reminder that one short flyby captured at one specific moment of an 84-year orbit can only ever offer a single snapshot of a planet that changes dramatically across the course of its own extraordinarily long year. That's exactly why there's now a serious, active push within the planetary science community to send something back. Rather than another brief flyby, researchers are pushing for a dedicated orbiter, a spacecraft capable of circling Uranus for years at a stretch, paired with an atmospheric probe that could plunge straight into its clouds and sample their chemistry directly, the way NASA once did at Jupiter. A mission like this has already been ranked among the highest priorities in planetary science for the coming decade, though realistically it likely wouldn't launch until sometime in the 2030s, with a journey of another decade or more required just to reach the planet afterward. If it happens, it would mark the first time in well over half a century that a spacecraft gets a sustained, proper look at Uranus, rather than the handful of frantic hours Voyager 2 had to work with. Nearly 40 years on, no other spacecraft has ever gone back. Almost everything we think we understand about Uranus's magnetic field, its interior, its unusual chemistry, and its shadowy ring system still traces back to that one narrow window in January 1986, a matter of hours of close-range data, some of which, as newer research suggests, may have caught the planet behaving in an unusually extreme, non-typical way. Until a new mission finally makes the trip, everything we know about what's really happening inside Uranus rests on one extraordinary fleeting encounter from decades ago, when a small robotic explorer swept past a planet that looked perfectly calm from a distance and discovered it was anything but.